Okay, let's dive in. Milk. It's such a staple for so many people, isn't it?
Oh, absolutely. It feels fundamental.
But it's also one of those foods that generates so much, well, debate. Is it actually good for us, or should we be avoiding it? The messages are all over the place.
Yeah, completely. You see one headline saying it's great for bones, the next saying it causes inflammation, then maybe it prevents one disease but causes another. It's really hard for people to track.
Exactly. Which is why we wanted to do this deep dive. We're looking at a really significant piece of research today, one that tries to bring all that conflicting evidence together.
That's right. We're focusing on what's called an umbrella review. It was published in NutriMetabolon in 2021 by Zhang and colleagues.
An umbrella review. So that's like a review of reviews.
Precisely. It's considered one of the highest levels of evidence synthesis. These researchers didn't run a new experiment. Instead, they gathered together 41 existing meta-analyses.
41.
Yeah, and those meta-analyses covered 45 different health outcomes linked to milk consumption. So it's a massive overview.
Okay, so they're looking at studies that already synthesized other studies, the goal being to kind of zoom out and get the clearest possible big picture from everything out there.
Exactly that, to see, what does the weight of the evidence really suggest about the pros and cons of drinking milk, especially for humans, and maybe help inform dietary guidelines.
And just to be clear, this was specifically about cow's milk, right? Not cheese or yogurt or anything else.
Correct, just cow's milk. They intentionally left out other dairy products and milk from goats or sheep, for example, because the nutritional profiles are quite different. It would just get too complicated otherwise.
Got it. Cow's milk only. So, okay, before we get into the 45 different outcomes, what's the headline finding? If you had to sum up this huge review in one sentence.
The main overarching conclusion was that, looking across all those outcomes, milk consumption was, and I'm quoting here, more often related to benefits than harm.
More often related to benefits than harm. Okay, that sounds pretty positive, actually, considering all the noise.
It is a significant statement. And based on that overall finding, the authors concluded that their results support including milk as part of a healthy dietary pattern.
Right. So the big picture leans positive, but more often implies there were some harms or potential downsides identified too. Let's maybe start with the good news first. Where did they see the strongest evidence for benefits?
Okay, yeah. Let's start there. Cardiovascular health was a really notable area. Interestingly, just comparing, say, super high milk drinkers versus very low milk drinkers didn't always give a consistent picture across studies.
Huh. So not just high versus low.
Right. But when they looked at the dose response, that's how risk changes. With each additional amount of milk, things got clearer.
Dose response. Okay, so what did that show?
This is pretty striking. For every extra 200 milliliters of milk per day, it's about one standard glass, roughly a cup.
Just one glass.
Like this one glass increment was associated with a 7% lower risk of stroke, a 6% lower risk of overall cardiovascular disease, and a 4% lower risk of developing hypertension.
Wow. Okay, so that's suggesting that adding even just one glass a day might have a measurable protective effect on some really major heart health issues. That feels quite substantial.
It does. But there's an important little twist, a nuance here. When they looked specifically at high-fat milk, that was linked to a slightly higher risk of stroke, about 4% higher per 200 gram a day increase.
Ah, okay. So overall positive for heart health, but the fat content might matter specifically for stroke risk. That's fascinating.
Exactly. It highlights how the type of milk could play a role.
Did the review touch on why milk might be having these effects, the mechanisms?
Yeah, they briefly mentioned what the original studies proposed, things like certain bioactive peptides in bulk that might help lower blood pressure, calcium, playing a role in blood lipids, maybe helping excrete some fat.
Interesting.
Also things called milk polar lipids, or MPLs, which might reduce cholesterol absorption, and even certain types of saturated fats, C15 and C17, which some evidence suggests could actually be protective. Oh, and CLA and sphingolipids too. It's complex.
Well, it really sounds like milk isn't just one thing. It's a whole collection of components working together.
That's a good way to put it.
Okay, so cardiovascular health generally looks good, especially with dose response, but watch the fat content for stroke. What about cancer? That's another area where you hear such conflicting things.
Right. And this review does provide some clarity, but also some complexity. For colorectal cancer, or CRC, the evidence was pretty consistent. Higher milk intake was linked to a decreased risk.
Decreased risk. By how much?
The pooled results showed about an 18% lower risk for high versus low consumers. That's a relative risk of 0.82.
18% lower risk for colorectal cancer?
Yeah,
That's a strong signal.
it really is.
No.
And they mentioned one specific meta-analysis included in the review. It had over 1 million participants that found lower risk for both colon and rectal cancer.
Wow.
And again, the dose seemed important. Adding about 1 serving of milk per day was linked to a 10% lower risk of CRC. They also specifically noted that low-fat milk showed a significant link to this decreased risk.
Low-fat milk being key for CRC protection. Okay. Any ideas why? What are the proposed mechanisms there?
The source pointed to a few possibilities. Calcium, again, potentially binding bile acids and fatty acids in the gut that can irritate colon cells. Vitamin D, which milk is often fortified with, might be protective.
Uh-huh.
Also, certain dairy fats, like conjugated linoleic acid, CLA, might inhibit cancer cell growth. And things like butyric acid, another fat, or even bovine lactoferrin, a protein, potentially playing roles in slowing down cancer or polyp growth.
So quite a few potential biological reasons for that protective link. Okay, so we've got cardiovascular and colorectal cancer looking largely beneficial. What about metabolic health, things like diabetes, obesity?
That was another area showing mostly positive associations. Higher milk intake was generally linked inversely to the risk of type 2 diabetes, metabolic syndrome, and obesity.
Inversely, meaning lower risk with more milk.
Exactly. Comparing high versus low consumers, the pooled results showed roughly a 13% lower risk for type 2 diabetes, about a 21% lower risk for metabolic syndrome, and around 19% lower risk for obesity.
Those are pretty decent numbers. Was there a dose response finding here too?
Yes. For every 200 gram per day increase again, about that one glass, they found an association with a 13% lower risk of metabolic syndrome and a 16% lower risk of obesity.
That's quite a strong signal again, suggesting milk might really play a role in protecting against these common metabolic problems. How might that actually work?
Well, the proposed mechanisms involve several components. Calcium and magnesium are mentioned. Milk proteins, like casein and whey, might help with blood sugar regulation and also make you feel fuller, enhancing satiety.
Ah, the satiety factor. Makes sense.
Right, and certain fatty acids found in milk, like trans-11 vaccinic acid and linoleic acid, plus those milk polar lipids again, and vitamin D. It seemed to be a combination influencing how your body handles sugar and fat, and maybe helping manage weight.
Okay, makes sense. And what about the classic milk connection bones? Skeletal health.
Right, the calcium connection. Here they look at osteoporosis and hip fractures. For osteoporosis, they found a really strong dose-response link. Every additional 200 grams of milk per day was associated with a substantial 39% lower risk.
39% lower risk of osteoporosis per glass. That's huge.
Yeah.
It really seems to back up the traditional wisdom about milk and bone density.
It certainly does for osteoporosis risk. But what's interesting is that this review did not find a consistent relationship between milk consumption and the risk of hip fracture.
Oh, so good for bone density maybe, but not necessarily translating into fewer hip fractures in this analysis.
Yeah, the link to preventing the actual fractures wasn't as clear from this specific synthesis of studies. It's a subtle but important distinction.
Definitely a useful distinction. Okay, last one on the benefit side. You mentioned neurological outcomes were kind of mixed. What was the positive finding there?
The main beneficial link they found was for Alzheimer's disease. High milk intake was associated with a decreased risk. The odds were about 37% lower compared to those with low intake.
37% lower odds for Alzheimer's. That's potentially very significant. What's the thinking behind that possible protection?
The proposed mechanisms include things like certain milk peptides, possibly helping to reduce inflammation and oxidative stress in the brain, which are factors in Alzheimer's. Also, a specific protein, casein, might inhibit the clumping of those amyloid beta proteins you hear about with Alzheimer's. Calcium and magnesium might play a role too.
Okay, so quite a list of potential benefits. Heart health, colorectal cancer, metabolic health, bone density for osteoporosis, and maybe Alzheimer's. That covers a lot of major health areas.
It really is.
But, as you said, the conclusion was more often beneficial, not always. So let's pivot to the other side. Where did this big review find potential downsides or increased risks associated with milk?
Right, this is where the picture gets, well, more complicated. It really shows that how food affects us is rarely simple. The most consistent potential harm they flagged was related to prostate cancer.
Prostate cancer. Okay, how was that linked?
Comparing low consumers to high consumers, high milk consumption was associated with an increased risk, about an 11% higher relative risk overall.
11% higher risk. And was there a dose response finding here as well?
Yes, there was. Each 200 gram per day increment that daily glass, was linked to about a 3% increased risk of prostate cancer.
Okay, a smaller percentage increase per glass than some of the benefits, but still an increase.
Right. And what makes it even more complex, frankly, is that some studies discussed within this review also associated low-fat milk consumption with a significantly increased prostate cancer risk.
Wait, low-fat milk, but didn't we just say low-fat milk seemed protective for colorectal cancer?
Exactly. That's the kind of confusing contrast this research highlights. Lower risk for one cancer, potentially higher risk for another, with the same type of milk. It really underlines the complexity.
Wow. Yeah, that's tricky.
And there's more nuance. The discussion in the review mentioned one study suggesting that high milk consumption during adolescence, specifically ages 14 to 19, was linked to a much higher risk, like 3.2 times higher, of developing advanced prostate cancer later on.
In adolescence, that's a really specific window.
It is. And they also noted some evidence linking ongoing milk consumption to recurrence or progression if someone already has prostate cancer, like whole milk over 4 servings a week or high-fat milk over 3 servings daily, being linked to higher mortality risk for men with localized prostate cancer.
So for prostate cancer, it seems like a pretty consistent signal of increased risk with higher intake overall, maybe complicated by fat content and potentially even influenced by intake years earlier. Any idea why milk might increase this specific risk?
The main theory revolves around milk's effect on insulin-like growth factor 1, or IGF-1. Higher levels of IGF-1 circulating in the body have been linked to prostate cancer risk and other research.
Ah, IGF-1. I've heard that mentioned.
Yeah, and this review noted that a 200-gram daily increase in milk was associated with significantly higher IGF-1 levels in some underlying studies. Other ideas involve casein, a milk protein, maybe promoting prostate cancer cell growth, or milk components potentially disrupting protective mechanisms involving p53 or DNA methylation. Also, the high calcium and phosphorus might decrease active vitamin D, which is thought to protect against prostate cancer.
Okay, so IGF-1 seems like a prime suspect there. Were there any other cancers showing an increased risk?
Yes, the review also noted associations between high milk consumption and increased risk for diffuse large B-cell lymphoma. That's a type of blood cancer, about a 49% higher risk. And also gastric cancer or stomach cancer, about a 44% higher risk compared to low consumers.
Okay, so prostate, DLBCL, and gastric cancer flagged as potential harms. What about other cancers like breast or lung?
For most others, they looked at bladder, breast, ovarian, endometrial, esophageal, liver, lung, pancreatic, and some other lymphomas. They generally found inconsistent results or no significant association in this particular synthesis.
Right. Okay, now back to the neurological outcomes. You said it was mixed. We heard the benefit for Alzheimer's. What was the potential neurological harm they found?
The harmful association was with Parkinson's disease. High milk intake was linked to an increased risk, about a 45% higher risk compared to low consumers.
45% higher risk for Parkinson's? That sounds like quite a strong link. Was there a dose effect there too?
Yes, the dose-response analysis suggested a 17% increased risk of Parkinson's disease for every 200 gram per day increase in milk.
17% per glass. Wow. Do we know why? Is there a clear explanation for this Parkinson's link?
This is where it gets really uncertain. The source itself says there are no clear explanations currently. They mentioned some potential ideas floating around in the literature, like maybe pesticide residues, organochlorines, or tetrahydroisoquinolines, sometimes found in milk supply chains, could play a role. Or maybe casein-reducing serum urate levels, and urate is thought to be protective against Parkinson's.
So just theories at this point.
Pretty much. And critically, the review authors state that based on the current evidence, limiting milk intake is not considered a reasonable prevention strategy for Parkinson's disease.
That's really important context. We see an association, but the cause isn't clear, and it's not strong enough to warrant telling people to avoid milk to prevent Parkinson's.
Precisely. It highlights the gap between finding a statistical link and understanding the biology enough to make a recommendation.
Okay. What about other potential harms or maybe side effects?
Well, one that might ring a bell for many listeners is acne. The review did find a positive connection here.
Ah, the milk acne debate. So this review found a link.
It found an association, yes. About a 48% increased odds of having acne linked with milk consumption. And this seemed to apply across the board: whole, low-fat, and skimmed milk. It was also related to how often people drank it.
And the mechanism there, still IGF-1.
That's the main suspect, yes. Milk increasing insulin and IGF-1 levels, which can then stimulate the sebaceous glands in the skin via a pathway called mTORC1. But, again, a little complexity.
Yeah.
They also mentioned that at least one study using a different method, Mendelian randomization, which uses genetic variations, failed to find this causal link.
So the observational studies mostly see a link, but maybe the genetic evidence isn't quite there yet. Adds another layer of,
Exactly. It suggests the relationship might not be straightforwardly causal for everyone or in all contexts.
And just quickly, did they find links for things like endometriosis or tooth decay?
No, according to this synthesis, no significant association was found for endometriosis or dental erosion.
Okay. And lastly, infant health. You mentioned iron deficiency anemia earlier.
Yes, this is a very specific but really important finding for that age group. High consumption of cow's milk in infancy was linked to a significantly higher risk, more than 3.5 times the risk, actually, a relative risk of 3.67, of developing iron deficiency anemia compared to infants getting follow-on formula.
Over 3 times the risk. That's a huge difference for babies.
It is, and it's quite concerning from a nutritional standpoint. The reasons are pretty well understood. Cow's milk itself is very low in iron. It can sometimes cause tiny amounts of blood loss from the infant gut, and things like the high calcium and casein content can actually interfere with the absorption of non-ham iron from other foods.
Right. So that's why standard cow's milk isn't recommended as the main drink for infants under 1.
Exactly. That's why iron-fortified infant formulas or specific iron-fortified toddler milks are generally recommended when transitioning from breast milk or formula rather than just giving them regular cow's milk from the carton.
Okay, that makes perfect sense. So we've laid out the potential benefits and the potential harms as identified by this massive review, but, we keep saying potential and association. It feels crucial to talk about the actual quality of the research that all these conclusions are built on.
Absolutely essential. This umbrella review is pulling together loads of existing analyses, but, as the authors themselves point out, the quality of that underlying research is, well, variable. They use specific tools to assess this, like AmStar2 for the quality of the meta-analyses themselves, and GRADE for the overall certainty of evidence for each outcome.
Okay, so what did those tools show? How good were the meta-analyses they included?
Well, using AmStar2, only about 11% of the 41 meta-analyses were rated as having high methodological quality. Many were rated moderate, low, or even critically low.
Critically low. Wow. Why would studies that are already meta-analyses get such low ratings?
One major reason highlighted was that many of the original studies within those meta-analyses failed to report their funding sources. That's a big red flag for potential bias.
Ah, okay. Transparency issues.
Right. And then looking at the overall certainty of the evidence for each specific health outcome using the grade system, the picture wasn't much better. None of the 45 outcomes were judged to have high-quality evidence supporting the association.
None. Not even for things like colorectal cancer or osteoporosis, where the links seemed strong.
Nope. According to their grade assessment, the vast majority of outcomes had evidence rated as only moderate, low, or very low quality.
So even when we synthesize everything at the super high level, our confidence in many of these specific findings isn't actually that strong.
That's the reality, yes. And it's largely because most of the evidence we have on diet and long-term health comes from observational studies.
Right, the ones that can show correlation but not necessarily causation.
Exactly. They show that people who drink more milk tend to have certain outcomes, but they can't definitively prove the milk caused it. There could always be other lifestyle factors, genetics, confounding variables, that are really responsible for the link.
Makes sense.
Plus other issues like inconsistencies between different studies looking at the same thing, sometimes limited sample sizes for certain analyses, and the potential for bias in those original studies all chip away at the overall certainty.
That is such critical context. We see these patterns, these associations, but we have to be careful about jumping to conclusions about cause and effect because the underlying research often just isn't strong enough for that level of certainty.
Precisely. The review also mentioned issues like heterogeneity, meaning lots of variability in the results of the studies being pooled, and likely publication bias. That's the tendency for studies finding statistically significant results to get published more easily, which can skew the overall picture you see in a review.
Right. The studies showing no effect might just sit in a file drawer.
Could be. And of course, the authors of this umbrella review itself acknowledge their own limitations too.
Like what?
Well, they only included findings that had already been published in a meta-analysis, so they might have missed newer individual studies or ones not included in those reviews. They mentioned it was hard to consistently analyze different types of milk, like full fat versus low fat, across all outcomes because the original studies didn't always report that detail. dose-response analysis wasn't possible for every single outcome. And they focused purely on disease outcomes, not on, say, intermediate physiological markers.
Okay, so we've covered a huge amount of ground here. The main findings benefits for heart, gut, metabolism, bones, maybe Alzheimer's, potential harms for prostate cancer, Parkinson's, acne, infant anemia. We've touched on nuances like dose and milk type, the possible biological reasons, common side effects like lactose intolerance, which affects what, up to 18% of people?
Yeah, the most with intolerance can handle about a cup.
Mm-hmm.
Okay. And also cow's milk allergy, which is much rarer, like 0.6 to 3%.
Right. And importantly, you mentioned this review found no evidence that milk causes general inflammation, maybe even the opposite.
Correct. They explicitly stated no evidence for a pro-inflammatory effect was found, and that some recent reviews actually suggest an anti-inflammatory effect,
Yeah.
even in people with metabolic issues.
Okay. And then the huge caveat about the quality and limitations of the underlying research. So bringing this all back together, what's the fundamental message you take away from this deep dive into this massive review about milk and our health?
I think based purely on this specific umbrella review, the main headline remains that the existing high-level evidence, taken as a whole, suggests milk consumption is generally associated with more health benefits than harms.
Supporting its role in a healthy diet overall.
Yes, the results lean that way, particularly highlighting those potential benefits for CVD, CRC, metabolic health, osteoporosis, and maybe Alzheimer's.
It's clearly not a simple milk is good story.
Oh, absolutely not. The complexity is undeniable. You have those potential harms for prostate cancer, Parkinson's, acne, infant anemia. You have the nuances around fat content affecting stroke versus CRC risk. It's complicated.
And all of it has to be interpreted through that filter of research quality, knowing that most of these are associations from observational studies with moderate to low certainty.
Exactly. This review gives us the best synthesis of what's out there, but it also clearly shows us where the evidence is still lacking certainty, which is why the authors themselves make a strong call for more well-designed randomized controlled trials.
Right, the RCTs, to try and nail down that cause and effect relationship more clearly for some of these links.
Precisely, to move beyond just observing correlations.
Okay, so let's leave our listeners with this final thought. This deep dive into a major review shows milk is complex potential benefits, potential harms, varying evidence quality. Given this really nuanced picture for such a common food, how does this affect how you think about incorporating milk or advising others about it? Does knowing that the science, even at this highest level, still has uncertainties and calls for more research, change your perspective on making dietary choices about long-standing staples like milk?
It certainly moves the conversation beyond just simple good or bad labels, doesn't it? It forces a more thoughtful look at the balance of evidence, the specific context, and, yeah, acknowledging the uncertainties that still exist.